All right, so think about this. You leave both of these cars out in the sun all day long. All right, which car are you going to want to get into if it's a hot day and it's been sunny out? Right, the white car has reflected all the wavelengths back. The black car has absorbed all those wavelengths. So it says white light reflects all the colors of the spectrum. Black absorbs all the colors of the spectrum. The black car will absorb significantly more energy throughout the day. Look at our little diagram up here. So for our diagram, we've got white light, which is hitting the black car, and it's absorbing, the black car is absorbing all the wavelengths. Whereas this, I know it's clear, it should be white. But all the colors are hitting this panel right here, which should be white, and it is reflecting all those colors back, which is kind of neat. That's pretty neat. I think it is. Okay, so let's talk about light and color. There's three primary colors of light. This is different than art class. Okay, science class is different than art class because with the three primary colors of light, when they are equally mixed, they make white light. In art class, you mix the colors and you get like brown or black. But in science class, you mix the colors and you get white. At least in terms of light, right? So take a look right here, this little diagram. So we've got the red, the blue, the green. You mix them all together equally. Right in the center, there's white, which is kind of crazy. If you look really close at an old TVs actually have pixels like this right over here. They have pixels like this. They've got the green, the red, and the blue. And when all those shine equally, you know what your eyes see when you're watching TV? Your eyes see white. Because you mix those colors together and you see white. Because those are the three primary colors of light, which is kind of interesting. Televisions and computer monitors, they combine the three primary colors of light in varying amounts. And that's how they achieve white light. I want to show you something, so I'm going to pause something real quick. Okay, so I want you to look at the webcam right now. So look at me. Oh, hold on, I'll bring myself to the center of the screen. Look at me here. And so I've got a color wheel. Take a look. It's got all these different colors in here. And you can see the different colors, right? But I can combine all those colors. I hope this works well over the computer. But if I combine all those colors, what do you think it's going to look like when I combine them? You ready? What do you see? What color do you see now? I see white. I see white, right? So you're mixing all the colors together, specifically the primary colors, and you can see light. There's a great video on, it's a brain pop on color. I can't give you access to brain pop, but hopefully we'll watch that together next time we're in class. So we're going to skip that right now. Okay, now that we've talked about colors and things like that, let's kind of move on to mirrors and how light is reflected. I suppose we should have talked about this back in the reflection section. But there's three major kinds of mirrors. One kind of mirror is called a plane mirror. And when I say plane, I'm not talking like plain as in yogurt, not P-L-A-I-N. It's P-L-A-N-E. P-L-A-N-E, that means flat. Like a plane. It's a tool that you use to flatten or straighten wood or something like that. A plane mirror, it produces a virtual image. That's an upright image of the same size. I got to be honest, you don't need to know the term virtual image. That's not testable material, but that's what it's called, is a virtual image. So let's go on. Oh, mirrors. That's the song. Okay, let's go on to another mirror, right? This next mirror is a concave mirror. A concave is like the inside of a bowl. Think of it like a cave that's on the inside. It says a concave mirror is a mirror with a surface that caves inward, like the inside of a bowl. It reflects light waves to form a focal point. Well, look at our little diagram right down here. So here is our concave mirror, and these red lines, those red lines represent light coming into that concave mirror. And as the light comes into the concave mirror, it's actually reflected back to one tiny point right in the middle. That's called the focal point, right? So all the light goes to one spot. That's why satellite dishes are curved like that. Satellite dishes got to be white. Because if it's white, it reflects all the wavelengths. There's no such thing as a black satellite dish. That doesn't make sense. You got a white satellite dish. It's reflecting all the wavelengths. And where does it reflect all the wavelengths to? A focal point. What's at the focal point? The antenna is at the focal point. You see that little black thingy there? That's the antenna, right? That is at the focal point of the mirror. So here's some examples of concave mirrors down here. The thing is, when you're really close using a concave mirror, you can see the image right side up. But if you pull the concave mirror far enough away, that image will actually look upside down, right? It'll look upside down. Let me get a mirror for you real quick, and we'll take a look at this and see if this works on a computer. I have no idea. We'll find out. Okay, so I've got a concave mirror right here. You could, if you don't have a concave mirror, and you probably don't at home, you could use the inside of a spoon. And if you're looking at this concave mirror, you might be able to see that my computer screen is actually upside down. I don't know if you guys can see that or not. My computer screen is upside down. But as we get closer and closer and closer, it's going to get right side up. Why is that? Well, take a look here at our little diagram. In a little diagram, the upper wavelength of light, the upper portion, reflects and then goes down over here. So actually, if this was the head of a stick figure, the head of a stick figure would hit this part, not the head, but the image from the head, would hit this part of the mirror and would reflect down. So that means if you're beyond the focal point, whatever you're looking at will be upside down, which is kind of neat for a concave mirror. I think I've got a video that goes along with that. And I'll have that linked in the description down below. So there's a bunch of videos that go along with this. Please make sure to watch those. That will help out a lot. Take a look. In the left-hand side right here, the candle is beyond the focal point. That's why it's upside down. Here, it's inside the focal point. When it's beyond the focal point, it's upside down. Okay? So if that's a concave mirror, let's take a look at a convex mirror. A convex mirror kind of does the opposite. A convex mirror is a mirror with a surface that curves outward. It's like the outside of a spoon, not the inside. Here's a convex mirror. The images in a convex mirror are right side up, but they're distorted. It reflects light waves outward, and it produces a virtual image. Again, you don't necessarily need to know what a virtual image is, but it's a regular image. It's not upside down or backwards. So here's your convex mirror, kind of like in this corner, and it helps you see around corners. Sometimes they have these in kind of like a blind turn at a street or something like that. And take a look at the size of the candle. Here's the real candle, and look at the size of the candle here. It looks smaller. The reflection looks smaller in a convex mirror. There's a short video that goes along with convex and concave mirrors. I encourage you to watch that. Okay, on the lenses. There's concave and convex lenses. A concave lens is thinner in the center. So here's a concave lens. It's thinner in the center. And sometimes it's used in eyeglasses. Okay? So, if take a look at the rays here. Here's the rays coming out of a light box. And as they go through the lens, they're refracted outwards. So they're refracted outwards here. Okay? Which is very different than a convex lens. What are concave lenses used for? Not much other than glasses. Not much that I can think of. On the other hand, a convex lens. A convex lens is the lens that we actually have a lens inside our eye. It's behind our iris, right? It's kind of part that makes up just beyond the pupil. It's thicker at the center, and it causes light rays to meet. I spelled meet wrong. Sorry, my bad. At a focal point. It's used in lots of optical equipment. And take a look at these light rays going through the lens, right? What's happening to the light rays as they go through the lens? They meet up at a focal point. They meet up at a focal point. And right now you're probably thinking, wait a second, if they meet up at a focal point, that means the image beyond there has to be flipped upside down. That's right. The image is upside down if it's beyond the focal point. This kid in this picture is using the focal point of a magnifying glass. It's taking all the light that's going through the magnifying glass, It's being focused at a focal point, and he's burning ants with it. That's probably something I did when I was a kid. If you go beyond the focal point, again, the image is upside down. And you might be thinking to yourself, Mr. Wagner, you said we have these in our eyes. Does that mean everything that we see is upside down? Well, not everything that we see is upside down, but our eye sees it upside down. And you might say, that doesn't make sense because it doesn't look upside down to me. Our brain flips it right side up. So the image that comes into our eye, comes in normally, goes through our lens, flips upside down, and then hits the back of our eye. So we are actually seeing our entire world upside down. You and I see our whole world upside down. But our brain flips it right side up for us, which is awesome. So here's kind of a diagram of how that works. Okay? So you see that little diagram here? Here's the, like if I drew a little stick figure on this diagram, here's the head of a stick figure going through the top of the lens down here, and then beyond the focal point, that would be flipped upside down. Right? So everything that you see beyond the focal point in a convex lens is going to be flipped upside down. I got to be honest, you will see questions of convex and concave lenses on your test and a little diagram. You need to know how light behaves in a convex and a concave lens, okay, with these little diagrams. And like I said, I've got some more videos that kind of explain that down in the description. So please make sure you do watch those videos. Those will be very helpful to you. That's it for this lesson. I will not see you this upcoming Thursday, and then I will see you the following Tuesday. I hope you have a great and wonderful fall break, and let me know if you have any questions, and I'll do my best to answer those. I know we did go through this pretty quickly, but feel free to rewind, pause, do whatever you need in order to make sure that you can get all the information on this video. And I did go pretty quickly, but thanks for being patient.